Hi there! In this video, we'll be talking about exponents. So we'll start with the basics on exponents, then we follow on some laws, and then lastly, we show some properties on exponents. So this video will mainly focus on the lesson part of this one, so we'll not be showing examples that much out here. We'll be focusing on showing those that I have mentioned and some mini proofs on how we acquired that out. So let's start with exponents. So exponents is of the form a raised to b, where a refers to the base and b refers to the exponent, or you could also call it the index. So exponents are basically, the important here is this one, since this means that this is the number of times that the base is multiplied by itself. So for this one would look like a times a times a times a, wherein we multiply this b times. So that is how we represent it. So as an example, if we have 2 raised to 3, this one would become 2 times 2 times 2, since we multiplied 2 3 times, and this one is simply 8. And so that is how exponents work. Now let's look into some laws or rules on exponent. So we start off with the product law. So the product law states that given x raised to a times x raised to b, so same bases, different exponents, or it can also be the same exponent, this one is simply x raised to a plus b. So the key here is that the exponents, the bases are similar for both of them. So it's just an example for this one. If we have 2 squared times 2 cubed, this would look like 2 times 2 times 2 times 2 times 2. And this one would become this one. If we combine this 2 times 2 times 2 times 2 times 2, so it's simply 2 raised to 5. And this one is 2 plus 3. So that is how it works. Now for a mini proof of this one, since we can write x as x times x 8 times, and then we can write the x raised to b similarly, but b times. Then we simply, through commutative property, this one is x times x, and this one is a plus b times, since there are a plus b number of x's here, which in turn would become x raised to a plus b. So that's how it works. Now for the quotient law, similar to the product law, we have x raised to b all over x raised to b, and this one is simply x raised to a minus b. Now this one is easier to prove than the first one, since we can actually write x raised to a as x raised to a divided by x raised to b, which in multiplication, it would become x raised to a times x raised to negative b, since that is how reciprocals work. And then we simply apply the product law, and this one will become x raised to a plus negative b, or x raised to a minus b. So that is how we acquired the quotient law. Let's go on the third one, the power of a power law. So this one is given by x raised to a raised to b is equal to x raised to ab. So when given this one, what we do is we multiply this b and a together. So it's not adding, it's multiplying this time. So to prove this, we're gonna write out x raised to a times x raised to a. So x raised to a, x raised to a, and we know that this one is b times. But through the product law, we simply add these exponents out here. So this one will become x raised to a plus a plus a plus a, and this one is b times. So it is simply x raised to ab, and this is true since multiplication is simply repeated addition. So it's just the definition of multiplication. Let's go on to the fourth law, the power of a product law. So this one is xy raised to a is equal to x raised to a y raised to a. So it's like distributing a to both of them. And for this one, note that xy raised to a is equal to xy times xy times xy times xy, and this one is a times. But through commutativity of multiplication, we can actually rearrange this one. So this one would become x times x times x is x times y times y times y times y. And we know that this one is also a times, and this one is also a times. So then we will have x raised to a times y raised to a, which is the answer that we are looking for. And we are able to acquire this through product rule. If we imagine that each of these has an exponent of 1. So that's how it works. Lastly, for the laws, we have the product of a quotient. So we have x over y raised to a is equal to x raised to a over y raised to a. So it's also like distributing the a's out here. Now this one is easier to prove since we already have the power of a product law. So we can write this one as x over y raised to a is equal to x divided by y raised to a. And this one is simply x times y raised to negative 1 raised to a, since y is simply, division is simply in multiplication is the reciprocal. So from here, we can apply the power of a product, which is just distributing the power out here. -1 times a, or simply negative a, and then returning back y to the denominator would give us x raised to a over y raised to a. So that is how we acquired these. So take note of this loss, as this will be essential in the whole study of algebra, especially we'll have some polynomials out there, wherein polynomials has a degree or an exponent of greater than 1. Let's end this with some properties on exponent. So we first have the zero exponent. This states that if x raised to 0, if we have this one is simply 1. And so the reason behind this is that if we apply the quotient law a while ago, we can have start with 1 can be written as x over x. So this is true by our knowledge in rational numbers, or specifically fractions. And this one is actually equal to x raised to 1 over x raised to 1. So applying the quotient law, this one is x raised to 1 minus 1. And this one would simply be 0. So that is where this one came from. So we could also try this for other values of x, like 3 to 50 or whatever number that is. The outcome will still be 1 or x raised to 0. Now we also have the identity exponent. And this one states that x raised to 1 is equal to x. I think this one is pretty self-explanatory, since again, the definition of exponent is that this refers to the number of times the base is multiplied by itself. So we only multiply the base by 1 time. So it's only x. And lastly, we have the negative exponent. I've been using this quite a lot a while ago and probably in the previous videos, but we'll explicitly state it out here. So this refers to x raised to negative a is equal to 1 over x raised to a. So just a simple proof out here. X raised to negative a through the what do you call this? The power of a power law. We can write this one as x raised to a raised to negative 1. And then we know that when it's raised to negative 1, this one is simply the reciprocal. So this one would become 1 over x raised to a. Or we can remove the parenthesis, so it would be similar to the outcome that we desire, which is this one. And so that is the basics on exponents. So I hope you learned a lot here, and take note of these laws and properties. And for our next lesson, we'll probably dive into some examples on applying these laws and properties, as well as some basic knowledge in exponents. So that is all for this video.